Okay, we're going to look at an expression here in probability, which comes up quite a bit, I suppose, and is related to a lot of things that maybe we've already even met in earlier chapters, but wouldn't have really gone into a huge amount of detail about, and that's going to be a factorial. So factorial is a way of us writing a multiplication of a certain number by every number below it down as far as 1, and we use an exclamation mark to represent factorial. And what I mean by that idea of multiplying by every number below it, I'm basically saying if you start at 6, so 6 factorial, we go 6, 5, 4, 3, 2, 1. Okay, if I start at 8, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so you're basically just multiplying by every number below it. We're not skipping any. Every natural number, I suppose, yeah, because whole numbers, but every natural number down as far as 1. Okay, and using that exclamation mark to represent factorial. Now where that can get a little bit more complicated is maybe when we're using a letter, a variable like n, but if I start at n, numbers below that are like n minus 1, n minus 2, n minus 3, and so on and so forth. Okay, the key notes here are the idea that 0 factorial is still just 1, okay, and also that each factorial is made up of other factorials. So let's even look at the example we had here. 6 factorial was 6 by 5 by 4 by 3 by 2 by 1. So I can already see that all of 6 factorial is included here. 6 by 5 by 4 by 3 by 2 by 1. So I can actually rewrite 8 factorial as 8 by 7 by 6 factorial. But I could equally rewrite 8 factorial as 8 by 7 factorial. Okay, and 6 factorial could be 6 by 5 factorial. Okay, because you're always just multiplying on the extra number, you're really just increasing these factorials constantly. We can use that rule particularly in trying to simplify some of these factorials without calculating them. So looking at the example here, 9 factorial, well that's 9 by 8 by 7 by whatever, down as far as 1. 7 factorial is 7 by 6 by 5, all the way down as far as 1. I should recognize that I will have the same expressions on both of these parts. So what I mean by that is I could rewrite 9 factorial as 9 by 8 by 7 factorial, so stopping when I've kind of reached a useful point to me. And I can see that I have 7 factorial on the top and the bottom. Because it's multiplication, that's a common factor that can divide in. And I get 9 by 8, which is 72. Okay, looking in terms of the n's here, which people no doubt find more confusing. If I start at n plus 1, the one term that is 1 below that would be n, because n plus 1 minus 1, so just n. Then n minus 1 here, and then n minus 2. And I could keep going, but I'll just use factorial to show, and then you would keep going. We'll have n minus 2 factorial on the bottom. I suppose the other reason that I've stopped there is that. And let's mark those in. And we get n plus 1 times n minus 1. Okay, we're not really asked to multiply it out, but n squared minus n, or n cubed actually even, minus n there, would give me my multiplication there. So let's do another example or two really of just reducing these factorials, okay? And it is important for you to have that idea of a factorial as being a multiplication of a number by every number below it, and how that kind of relates, and how you can use that then in rewriting different terms here. So looking at the 2018 example, we're asked to find a, b, c, and d, and we're given a complicated enough looking factorial expression here that we're asked to simplify. So what I know about n plus 3 factorial is if I start with n plus 3, then go 1 down, that would be n plus 2, then 1 down, n plus 1, and I'm going to stop there, okay, for reasons that we can hopefully already see. Same with n plus 2, if I start at n plus 2 and go 1 down, the next one is n plus 1, so I'll stop there as well, and then underneath I still have my 2 n plus 1s. Now again, I can see a common term here on top and bottom of n plus 1, and over here, I similarly have a common term of n plus 1 factorial. Okay, so what that will leave me with is n plus 3 times n plus 2 times n plus 2 times n plus 1. Okay, the fact that the factorials are written beside each other doesn't change the fact that terms written beside each other generally represents multiplication. So even though it was 2 factorials beside each other, they are being multiplied by each other. Now the reason I'm going as far as n plus 1 on both of those is solely because the n plus 1 is on the bottom. Okay, and I know that if I can rewrite the top parts to include that n plus 1 factorial, that's something that I can kind of get rid of then. So at this point now, it's a bit of multiplication for us. So n squared, let's kind of do this one out now in a few steps here. Oh, and excuse me, that shouldn't have n plus 1 at the end here, just n plus 3 times n plus 2 times n plus 2. So let's start, keep the n plus 3 to the end maybe. Okay, so the reason I know I'm content with 3 terms here is I'm looking for a cubed. So 4 brackets would have given me too much here. I'm multiplying this out. N cubed plus 4n squared plus 4n plus 3n squared plus 12n plus 12. So n cubed plus 7n squared plus 16n plus 12. We were asked to find A, B, C, and D. So A is 1, B is 7, C is 16, and D is 12. And that's our overall answer. We look at one more example here. N plus 3 factorial over n plus 1 factorial over n squared minus 4. So we're going to rewrite the n plus 3 factorial. So starting at n plus 3 times n plus 2 times n plus 1. Of course, I'm going to let that be my factorial to continue with because I know that n plus 1 factorial is on the bottom there. So that leaves me with n plus 3 times n plus 2. On the bottom, it's n squared minus 4, which is a difference of 2 squares. It can be written as n plus 2 times n minus 2. So I actually end up with n plus 3 over n minus 2 with a bit of factorizing there. Okay, so really all I'm looking at here is that idea of a factorial being a multiplication of every number below it and how we can use that even when it applies to variables here. And that's going to come up a little bit later in our combination rules and our permutations, maybe to a lesser extent.